says use the following conditional statements. Answer the following. If two angles are supplementary, then the measure of their sum is 180 degrees. The first question, first part A, says identify the hypothesis. What is the key word that we should look for to be able to identify the hypothesis? Stay on. If. Question. Is if actually a part of the hypothesis? No, it's just our signal word. It's how we know we found the hypothesis, but it's not part of it. So the words that come after if, all the way up until we get to the comma and the then. A hypothesis is a sentence. This should be a full thought. What do you start a sentence with? What type of letter? Capital letter. So you need to make sure to capitalize the first word. So this would be two angles are supplementary. Two angles are supplementary. For the hypothesis, what is my signal word for the hypothesis? Then. Is then a part of the hypothesis? No. This is also going to be a full sentence. If I walk up to somebody and say the measure of their sum is 180 degrees, are they going to have any idea what I'm talking about? We want to avoid pronouns when we write down the hypothesis. So in this case, there is a pronoun here. And you should put your phone away, please. What is the pronoun? There. What do they mean by there? The two angles. So when I write my hypothesis, instead of saying their sum, I'm going to say two angles sum, so that it's really clear. Now I don't sound as much of a crazy person. They still might look at me funny if I say them to this at the grocery store, but at least it will be a full and complete thought. So the measure of two angles sum is 180 degrees. Converse. We haven't done this for a while. Do you guys remember converse, inverse, contrapositive? Converse was the one that we learned about first. Switch, yes. Converse, we switch. What are we switching? The hypothesis and the conclusion. So instead of if two angles are supplementary, I wanted the first part to say what? Yes. If the measure of two angles sum is 180 degrees. I need a symbol after that before my next word. Comma. Before my next word, I put a comma at the end of my hypothesis. And what word comes after that? Then. Then what? Then they are supplementary, yes. Then they are supplementary. Pronouns are okay in the middle or the end of a sentence, but not at the beginning. At the beginning, we need the subject of the sentence. All right. Part D. Is it possible to write a biconditional for the conditional? If so, write the biconditional. If not, explain why / give a counterexample. How do I know if it's possible? Yes. We need the conditional, the original statement, to be true. And we need the converse to be true. So let's look at our original conditional statement and decide whether it's true or false. If two angles are supplementary, then the measure of their sum is 180. Is that true or false? That is true. My converse, if the measure of two angles' sum is 180, then they are supplementary. It's true. This is true. If you have two angles that add to 180, they're supplementary. If they're supplementary, they add to 180. That's just what it means to be supplementary. So can I write a biconditional here? Yes. There are 4 very special biconditional words that we use. What are those 4 special words? If and only if. Tomorrow when we get to the test, if you do not remember what a biconditional is, I will not be able to tell you. I will not be able to tell you that a biconditional uses if and only if. What I can do is, if you forget what a biconditional is, I could say, what are the 4 special biconditional words? And hopefully that's enough to jog your memory. Okay? Where does the if and only if go in the sentence? In the middle, in between the hypothesis and the conclusion. Is the word if actually part of the hypothesis? No. When we write a biconditional, we do not write an if at the beginning. I've got 2 ifs right here. I don't need a third one. So we do not write the if at the beginning. We start with the hypothesis. It doesn't matter whether I'm looking at this sentence or this sentence. This original conditional and the converse are made up of the same 2 parts. We are going to write one sentence and one sentence only. I could say the measure of two angles' sum is 180 if and only if they are supplementary. Or, what I'm actually going to write down, I can say 2 angles are supplementary if and only if the measure of their sum is 180. It does not matter which way you do it, as long as the if and only if is in the middle. So 2 angles are supplementary. If and only if you do not have to put yours in all capitals, but I'm putting mine in all capitals so that we don't forget that those are the 4 special biconditional words. If and only if the measure of their sum is 180 degrees. Absolutely beautiful. What else would you guys like to see from the review? Which one? 24. That's the very last one, right? Absolutely. Let's go look at number 24. We have a proof back here. Very back page. Does anybody remember what this type of proof is called? This is a flowchart proof. The other one is called a 2-column proof because it has 2 columns. This is a flowchart proof. Oh, Silas, you'd ask for the bathroom. All right. Why are we allowed to make this statement right here? Name, date, time, marker goes in the cat. It's the given. Kind of nice on this flowchart. We only have to fill in the reasons. We don't have to fill in the statements. Yes, sir. Yes, as long as we have enough time, absolutely. One of the things I wanted to let you guys know, on the proofs on the test tomorrow, unfortunately, you do not get to use the red paper on the test. However, for the proofs on the test, I will give you a word bank. So you still get things to jog your memory. It's not going to have as many choices on it as that red paper does. So I'm going to help narrow it down for you to make it easier to make your choices. Okay? So you don't get to use the red paper, but you do get a word bank. All right. let's look at this statement right here. Are there any boxes above this? No. Is it my given? If it's not the given, and there's nothing that came before it, where is this coming from? From the graph, from the picture. So this says angle 1 is congruent to angle 2. Well, here's angles 1 and 2. What type of angles are those? Vertical angles. So why am I allowed to say they're congruent? Vertical angle theorem. Vertical angle theorem. And I'm going to abbreviate that so that it fits inside the box. Definition of vertical angles would let me say angle 1 and angle 2 are vertical angles. If I want to talk about the relationship that those angles have to each other, they're congruent or they add to 180, then that's a theorem. So saying this is what it is would be a definition. Saying this is the relationship they have is a theorem. So far, so good? Are there any other boxes that don't have anything above them? Are there any other boxes that don't have anything above them? Angle 3 is supplementary to angle 4. Is that the given? So where are they getting it from? From the graph, from the picture. Look at angles 3 and 4. What do we call that special angle pair? A linear pair. When they're side by side, they're a linear pair. When they're on opposite sides of the x, they're vertical. These are a linear pair. Why can I say they're supplementary then? Linear pair theorem. Linear pair theorem. Again, to just say angle 3 and angle 4 are a linear pair would be the definition of linear pair. Talking about their relationship to each other is the theorem. All right. It says I'm going to use this box and this box to make this statement down here. So, I don't know, pick one of the boxes. What stayed the same between these two? 3. 3 stayed on the right. What changed between these two? 2 got swapped out for what? Are 1 and 2 the same size? According to this over here, they are. That's why we have to use this box too. We made a swap. As long as they're the same size, I'm allowed to swap them. Normally, I would say this is substitution. But we have a congruence symbol here, so what do we have to call it? Transitive property. This is our transitive property. And then we get down to our very last statement. It says I'm going to use this and this to make this statement down here. Well, this statement down here looks a lot like that box, right? Angle 3 and angle 1 got swapped out, but everything else is the same. Do we have congruence symbols here between these two? So when I make this swap, what am I going to be using? Substitution. That's our substitution property. Fantastic work. What else would you guys like to see from the review? Which one? 20? Absolutely. Let's go look at number 20. Oh, number 20, they didn't give us anything. We got to write the whole proof start to finish. But there's a couple things that I know how to fill in, right? What's the first statement that I can make? What is my given? GH, segment GH is congruent to segment JK. And why am I allowed to make that statement? Because it's the given. There's another statement that I can make without having to think too much about it. What's the other statement that I can make pretty easily? Yep, what it is that I'm trying to prove. X equals 58. Where does that go? down here at the bottom. X equals 58. Do I write prove right there? Proven? No. Do I have any way of knowing what this reason is yet? Nope. I got to know what this statement is before I'll know this reason, because I have to see what changes to figure out this reason. All right, let's look at where we're starting, look at where we're trying to get to, and see if we can figure out what our next step should be. So what do we have between these two letters? I have a congruence sign. When I get to the end, what do I want between these two? Equal sign. So I'm going to have to find some way of getting an equal sign in here. If I know that two segments are congruent, can I say anything that has an equal sign? Yes, what can I say? The length of segment GH, which is what it is when it's no bar over the top, equals the length of segment JK. Let's think about why we're allowed to say that. Here, what's that bar mean again? Means segment. I have a segment congruent to another segment. Segment congruent to another segment. Down here, I want to say that means they have equal measurements. Why can I say that? That's exactly correct. Definition of congruent segments. All right, we got the equal sign in there. That's good. The other thing that I notice about where I'm trying to go, it's got an X and it has a number. I don't have any X's or any numbers here yet. Where can I get some X's and numbers from? From the picture. What could I put in the place of GH? 7x minus 32. What did I just do? I took this out and put this in. Substitution. Is there anything that I can put in the place of JK? 6x plus 26. We just did substitution 2 times. So the reason I can do both of those is the same reasoning here, substitution property. All right. Thank you. Martin. Sorry, Martin asked next. And I don't think we will have time because it's 58 now. All right. Silas, is this your pencil? Okay. You're going to name, date, and time, please. All right. So now I got something that has X's. It's got numbers. I just now need to solve this for X. What would the first step be in solving this for X? Subtract 6x from both sides. What would that give me if I subtract 6x from both sides? X minus 32 equals 26. Why am I allowed to minus 6x from both sides? Subtraction property of equality. These boxes aren't big enough. All right. Now I'm finally here, which means I can see what changed. How did they get from here to here? What did they do? Add 32 to both sides. What property is that? Addition property of equality. Which I am abbreviating because I don't have a lot of room. Yes. If you added 32 to both sides first and then down here you minus the 6x from both sides, that would still be mathematically correct, yes. It's not my preference, but it's not wrong, and so it would get full credit. All right. Do you guys have any other questions for me on number 20? What else would you guys like to see? We got 23 minutes left. What else do you want to see? Number 1? Absolutely. It's been a hot minute since we've done any problems like that. All right, so number 1 says write a conjecture that describes the pattern in each sequence, then use your conjecture to find the next term in the sequence. So a conjecture is just a way of taking a pattern that I notice and putting it into words so that somebody else could follow the same pattern. So my sequence goes from 1 to 3 to 5 to 7. How are they getting the next number each time? Adding 2. So I would say the next term in the sequence is 2 more than the previous term. The next term in the sequence. So to find the next number, add 2 to the one that came before it. That's what I said. What is the next term in the sequence? $13. The next number would be 13. We would take 11 and add 2 and get 13. So far, so good? All right, let's look at part B then. Looks, at least at the beginning, like the same pattern. 2 plus 2 is 4, right? But can I keep that same pattern of plus 2 going? What are they doing? Doubling. They're timesing it by 2 instead of plussing 2. So I would say the next term in the sequence is double the previous term. So what is the next term? 64. Absolutely beautiful. Fantastic work. What else do you guys want to see? 17? Absolutely. I don't think I've done that one yet today. 17. Do you need me to go back, Ariel? Do you need me to go back? Okay. You got it? Okay. So 17, 18, and 19 are all really short. It's just a reason. Something from the red paper. Are you guys okay if we do all 3 of these since they're pretty short? Awesome. Okay. So my first question. Oh, those. Is it? Somebody show me your paper. I gotta fix those numbers. So 3 is in the right spot. 1 is supposed to be tucked into this corner right here. It's not supposed to be so far over. I don't know why it is that far over, but it is. All right. What is this a picture of? We got angles, right? All kinds of angles going on. These 2 would be vertical angles, right? What are these 2? That would be a linear pair. So based on what it says up here, I need to know whether I'm looking at a linear pair or vertical angles. Which angles do they refer to up there? It says 1 and 2 are supplementary. What type of angles are those? It's a linear pair. What about the other one, 3 and 4? Those are also a linear pair, yes. Why am I allowed to say that linear pair angles are supplementary? Linear pair theorem. Linear pair theorem. I love the next one. On number 18, I have an if-then statement, right? So if I'm thinking about this like a proof, the if part is the step that comes above. Then is what happens next. And I want to see what changed between the if and the then. So what's different about my if statement from my then statement? What changed? Do we have a ZP over here? Not on either side, do we? This had ZP on both ends. Yes. To get from here over to here, what did they have to do to get rid of ZP and ZP? Subtraction, yes. This is the subtraction property of equality. Subtraction property of equality. Whenever I'm looking at these statements like this, thank you, that's okay. We never write the property based on the if. We always write the property based on what changed between the if and the then. The if is just where I'm starting. We just take it at face value. And then what changed to give me my then? That's the property that got used. Number 19. Ooh, I like this one too. All of this is part of my if, right? It says 4 is congruent to 17, 17 is congruent to 9. And then here's my then. What doesn't show up in the then part? 17. Both 4 and 9 were the same size as 17. This is like a $1 bill is the same as 4 quarters. 4 quarters is the same as 10 dimes. So a $1 bill is the same as 10 dimes. That's basically what this is saying, right? The first thing is the same as the second. The second thing is the same as the third. So the first and the third are the same as each other. Kind of feels like substitution, except I got these congruent symbols. Transitive property. Transitive property. Absolutely beautiful. We got 15 minutes left. 2 to 3 questions, depending on how long they are. What else do you guys want to see? You said 21? Absolutely. This is a fantastic problem. Problem number 21 back here. Says using the figure to the right, the measurement of angle LJ or LKJ is 137 degrees. LKJ is this. This right here is 137 degrees. PKJ is x plus 5. Here's PKJ, right here. X plus 5 degrees. LKP, this angle right here, is x plus 90 degrees. So far, so good? We're supposed to find x, the measure of LKP, and we're supposed to explain what postulate or theorem or property we're using. Let's do this part first, because this is what we're going to have to use to solve up here. Almost a trick question, not actually a trick question, but think about it carefully. How many angles are in the picture? 3. What can I do with those 3 angles? Yes, I can add the 2 little ones to get the bigger angle. What do we call that? Angle addition postulate. We're going to use the angle addition postulate. So the angle addition postulate, you said we add the 2 smaller ones to get the bigger one. What are the names? Nothing with x's, nothing with numbers yet. What are the names of the two smaller angles? Yes. So we're going to take the measurement of angle LKP plus the measurement of angle PKJ, and that's going to equal my big angle. What's my big angle? LKJ. Perfect. Now that I have my equation written with small angle plus small angle equals big angle, yes? Should you write this out? Yes. Will it save you from putting stuff in the wrong spot? Yes. Will I take off points if you don't have it there, but you do it right anyway? No, I won't take off any points. If you do it right, I won't take off points, but this is how you know that you're putting the pieces in the right spot. Because what I've seen happen a lot on this particular test is that students will know that they're supposed to use angle addition postulate. The two smaller equal the bigger, but they'll just take this plus this equals this, because that's the order that they see it in up here. And so then they'll miss the whole problem. All right? But no, I won't take off any points if you don't have that part. LKP, what goes in the place of LKP? X plus 90. Drop my plus sign down. What goes in the place of PKJ? X plus 5. Drop my equal sign down. What goes in the place of LKJ? 137. And now we're going to combine our like terms together. I have x and x that combines to give me what? 2x. And then we have the constants. Constants are things that don't have variables with them. What do I get when I combine the constants together? 95. 2x plus 95 equals 137. Now what do I do? Subtract the 95 from both sides. I would need a calculator for this. What is 137 minus 95? 42 is what I heard. Is that right? Okay. I don't have my calculator on me. I'm trusting you guys for this. Then what do I do? Divide both sides by 2. What's half of 42? How much? 21. Sorry, I just didn't hear you. X is 21. We still need LKP. The measurement of angle LKP was x plus 90, right? So we're going to do 21 plus 90. What is 21 plus 90? 111 degrees for LKP. Nicely done. We have 8 minutes left. 1 or 2 more problems. 2 if they're really short. 1 if they're not. What else would you guys like to see? Which one? 23. I don't think I've done that one yet today. 23. Oh, yes, I have. I've done this one. What will my first statement be? Segment XY is congruent to WU. Anything else? XZ is congruent to ZU. Absolutely. They already gave me my reason for that. We can make that statement because it is the given information. It tells me that the next reason is the definition of congruent segments. Do we have any congruent segments? These two are congruent, and these two are congruent. What does it mean to be congruent? The same size. What symbol can I use if they're the same size? Equals. So the length of XY equals the length of WU, no bar over the top, because now I'm talking about how big it is. And the length of XZ, no bar over the top, is equal to the length of ZU. So far, so good? All right. Let's look at statement 3. Well, I see XY right here. I see WU right here. From the XZ right here, get out of my way, I see XZ right here, and I see ZU right here. But it looks like there's two things here that haven't been talked about up above. What two things are there here that we haven't talked about yet? YZ and ZW. Well, if it didn't come from up here, where's it coming from? From the picture. Let's go find these segments on the picture and figure out why we're allowed to say this. This says XZ, XZ is this whole long segment right here, equals XY plus YZ. What are these? Segments. And I'm putting two smaller segments together to get a bigger segment. Why can I do that? Segment addition postulate. Segment addition postulate. Okie dokie. Whew. I'm going to check out where I'm trying to get to. I'm going to see the statements down below to see if I can figure out where I'm supposed to go next. So looking down below, I see YZ, which is right here, and ZW, which is right here. So these are the two things that I want left over at the end. And I want them to be in a single equation. Right now I have two equations, but I only want one. XZ is right here, right? What is the same size as XZ? ZY plus YZ. So I can take all of this right here and make it take the place of XZ. So I can say XY plus YZ equals. What did I just do? Substitution. On the other side here, I want a ZW. Well, here's where I see ZW. ZW plus WU is equal to ZU. How can I use that here? What can I do? ZW plus WU. I'm going to take all of this right here. All of that is the same size as ZU, so I'm going to make it take the place of ZU. ZW plus WU. We just did substitution. Do you guys see what we substituted? All right. I want YZ to stay right where it is. I want ZW to stay right where it is. I want this to go away, and I want this to go away. But I can't make it go away yet. It says I'm going to use the substitution property again. But why can't I just make these two things go away? They're not identical. They're not exactly the same. This either has to be changed to a WU, or this has to get changed to an XY. Can I do a replacement like that? Yes. We were told right here that those are the same size. So I can say WU plus YZ equals ZW plus WU. We made a substitution here. And now why would I be allowed to get rid of WU on both sides? Subtraction property of equality. All right. Last reason. These look almost identical. What's the difference between the last two statements? This is equals, and this is congruent. Why can I say two segments that have equal measurements are congruent? Not angles, but segments, yes. Definition of congruent segments. What do I have on Canvas to help you? Answer key. Where do you find that at? Got to go to modules. Where do I want to go once I'm in modules? 3A. You got to find 3A, and then where? Today's date. So today is the 16th, which is down towards the bottom of the module right here. 9/16, review for the module 3A test, day 2. Click on that. As you scroll down, here's the videos from first and second period. Third period will be going up here in just a minute. Seventh period will go up later. But for you guys, the first 3 videos would be helpful because I answered different questions then. Go all the way to the very bottom. This is where the answer key is. It shows all of my work. So you will have answers for every single problem. You're going to turn in the answer key, not the answer key, you're going to turn in your test review, hopefully with all the answers on it, tomorrow before you take your test. Do you guys have any questions for me? All right. Happy studies at all this evening. Send me messages in Canvas if you get stuck on anything. Have a great rest of your day, guys.